All right, here we have a vector. It's the vector 4, 3. So we think of that as a movement in the coordinate plane, 4 spaces to the right, 3 spaces up. And we represent that in a drawing by showing a little line segment with an arrow on it because it has a direction. Just going from the origin up to the point 4, 3. Kind of represents what that movement would look like if it started at the origin. So a vector, by the way, in general, is just something that has what's called a magnitude, which in our case is a length and a direction. So this direction so far, right? That's what a vector is. And this vector, by the way, I mean, we should recognize that it's 4, 3. It's that 3, 4, 5 triangle. So its length is 5 units. Which we wouldn't have to draw the picture for that if we need to do Pythagorean theorem, because we could always just use Pythagorean theorem with A and B being the components of the vector. So the question comes up is, well, what if I wanted to have a vector that was the same direction, still in this direction, but say it had a different length? Say, for example, I wanted to do a vector that was twice as long as this one, so 10 units long, but still in the same direction. Well, I hope that this makes sense, that I would just go over 4 and up 3, and I would just do that again. Right? Over 4, up another 3, so that overall I would be at, let's see, that's 8, 6. So the vector 8, 6 will be 5 and another 5 units for a total of 10 units. It's twice as long, but it's in the same direction. Okay? Or what if I wanted to have a vector that was going in the opposite direction, right, but the same length? Right? So I could go, well, kind of keep along this line here. I would go 1, 2, 3, 4 back, and 3 down. And I would have the vector -4, -3. And that vector is also 5 units in the opposite direction. And notice that I could achieve this without drawing the picture just by, for example, if I want to find the vector that's twice as long, I would just double the components of the vector. So 4 times 2 is 8, and 3 times 2 is 6. Or if I want to find the vector that goes in the opposite direction but it's the same length, I just, well, think about this, I'm multiplying the coordinates, or the components of the vector, not coordinates, components of the vector, by -1. 4 times -1 is -4. 3 times -1 is -3. And I could apply this to finding vectors that go in the same or opposite directions, but are all sorts of lengths. So say, for example, I want to find the length of a vector that's half of 5, or 2.5 units long, but still goes in the same direction. Well, see, if I look here, that would be half of 4 is 2, and half of 3 is 1.5. If you look, over 2, up 1.5, right there. Here is our 2.5 length vector. Or maybe I wanted to do just 1 unit. What's just 1 unit, right? So I would want to divide this whole length of 5 by 5. So I'll just divide each of these. Oops, I made this. Right? So if I go like this, 4 divided by 5, and 3 divided by 5, that would give us our vector that was just 1 unit long. So I'd do a little triangle and make over 4/5 and up 3/5, so it's like somewhere right around here, right? Just a single unit long. And if we were to apply Pythagorean theorem here and check it, we'd have 4/5 squared plus 3/5 squared equals c squared. So that's 16/25, and 9/25 is c squared. That's 25/25 is c squared, or 1 equals c squared, or 1 just equals c. Right? So the length of that vector is just 1 unit. So if I want to find, I can find a vector of any length I want, especially if we get this unit vector, right? Just this one this unit vector now. Now I can find a vector of any length I want simply by taking this unit vector now and just multiplying the coordinates by the length I want. So if I want a vector that's 53 units long, well, it's 53 times 4/5, 53 times 3/5, and that's my vector, whatever that works out to. Right? If I want to find a vector that goes in the opposite direction and is 27 units long, well, it's going to be negative 27 times 4/5, comma, negative 27 times 3/5. And that vector will go in the opposite direction, this direction, and it'll be 27 units long. So anything I want, I can do pi units, whatever, square root of 2 units, doesn't matter. So, again, if I want to find a vector that goes in the same direction as the vector I have, but is longer or shorter, all I really have to do is scale that vector down to 1 unit length by dividing by its overall length, by dividing each of its components by its length. Right? So this was length 5, so I had to divide the x component by 5 and the y component by 5, and that gives me my unit vector. And then I can multiply that unit vector by whatever length I want to get a vector of any length and goes in the same direction. And if I want to go in the opposite direction, then I just multiply that unit vector by the negative of, and then whatever length I want.